So basically, we are not going to build the whole economic module because if you can see, it's rather complex, even though this is a very, very simplified model. And then anytime you can think about a specific feature, a specific issue that we are not coping with here. So there's someone in the chat. Okay, thank you, maybe. Thank you for your comment. So of course, the model is very complex, so it would be very tough to build this from scratch during a lecture. So I decided to do this template following a suggestion of David, actually. And then you have the PDF, a written exercise where we have like a step of what we should do. So I can read the PDF, and basically is much more simplified than William, of course, but it follows a similar reasoning. So we have a demand-driven output. We have constraints in the potential output side. So these constraints, they come not only from the capital availability, but they also can come from material side, for instance. And all these components, they have dynamics. This will lead to employment, to income distribution. Yeah, so this lower part where we can have an employment, and then also this idea that this is not a market clearing model, so we can have positive unemployment rates and persistent unemployment as part of the model. So the first exercise, I think the template in the file is the one from day 2. Okay.
Yeah, maybe I should have shared my screen because I'm still seeing forests and CO2 and waste materials and fossils.
But isn't there a folder for day 3?
Yeah, and the file is named day 3 template, but it's
Okay.
where we left off from day 2.
But you can change the view here, no?
Ah,
Economy. You can navigate in the
there you
views.
go. Perfect.
And you find the same
Question
thing,
solved.
the things in green.
Oh, this got huge.
Yeah, so thank you, Jay, for the... So I will open the comments as you in the chat because we need this to be minimally interactive. So we have different views. So in each of the views, you have part of the model, which is very useful. Otherwise, it becomes really a mess. And then we are going to work in the economy view today. Yeah. So the first part of the exercise is to compute final demand. So we have final demand, which is composed of consumption, investment, and government spending. So in this very simplified model, we are working with a closed economy, so we don't have international trade. So each of these components, they have its own dynamics. So consumption depends on labor and capital, income, and also on wealth. We have propensities to consume out of each of these variables. Invest depends on the expected sellings, on the utilization of capacity and the capital stock, and government demand is exogenous with respect to the current income flow. So we will add a rule for the growth of government spending. So the first point is to just open the file, open the view economy, and connect each component of demand with the final demand variable. And then we can write the formula for the final demand in the respective variable. So remember, we can create variables using the variable tool here, and we can connect them using the arrows, the blue arrows. And then we have here final demand, and the components are investment, government spending, and consumption. Also using this tool, the equation tool, we are able to open the variables. So for instance, I want to check consumption, and we can see what's the formula, how the variables that are composing determining the dynamics of consumption, how they interact. So if they're multiplied, added up, if there's any number here, and this changes the behavior of this variable in the model. So what the exercise is asking us to do is just to take an arrow and connect the variables. So it's pretty simple. And then We can open final demand. We're going to see the variables that we connected here in this small box on the right bottom part. And then we had, in the beginning, before we had a value of our final demand that was equal to 0. So we can say, okay, final demand is equal to consumption plus government spending plus investment. And that's it. So if we do that, then we can check the syntax of this equation. Everything is okay. So we have already an equation for the final demand. Okay. So this is the first step of this model. But we are only calculating the final demand for now. So we still do not know what the amount of output of the economy. So if output is driven by demand, so the variable output that's below here will be caused by the final demand. But still, we have to take into account the potential output, so the possibility of having a constraint from the supply side that does not permit that the total demand creates the proportional output. There can be some constraint from this side. And this is particularly important if we want to consider constraints related to the availability of materials or the impact of climate damage on productive capacity. So if climate damage reduces the capital stock, we have a fall in the potential output from the capital side, and then we can have an effect on the production itself. So how can we include these effects in output determination? Moreover, if supply constraints are active, they must also affect the level and pace of growth of demand and not only current output. So Iñaki earlier was explaining to us that what happens in William is that when we have this scarcity coming from the excess of demand with respect to the potential output, there is an increase in prices, right? So for instance, he was saying that when we have climate damage, we have a damage on the capital stock and labor productivity. This leads to an increase in prices, and then it reduces demand due to the fall in the real final demand. So nominal demand is the same, but real demand falls. But here we are not going to deal with prices because this is a very simplified model. We have only one good, one sector in this. I mean, we have three capital goods, right? We have energy, materials, and capital, but only one consumption good. So the prices to consumer are is equal to 1. And of course, to do something more complex, we would not be able to use the free version of Vensim that you guys have available. So we are going to keep it simple. And then the solution that we found was to have a rationing rule. So a rule that reduces demand proportionally to the potential output when the final demand is higher than the potential output. So we have someone writing in the chat. Okay, no, it's Robert about the deliverable. Okay. So now the second part is to use the function min. There's a function min that selects the minimum variable between minimum value between two variables, and with this function we can make output dependent on the minimum value between final demand and potential output. So what's the idea? We have potential output here, right? We have output, we have final demand. So we can do the following. We can connect the two variables to output. Then we open the equation for output. We can write min. And then what we are doing here, we are saying that the value of output will be the smallest among final demand and potential output. So where I put potential output delay by accident. Yeah, we don't need that actually. Potential output is below here, right? So again, mean. The output will be the smallest between these two variables. This means that if final demand is, for instance, 200 and potential output is 150, then of course the output cannot be 200, right? It must be 150. But if demand is below the potential output, then there's no reason why the economy would be producing at this maximum capacity, because then in this point of view, it's constrained by the level of demand. So this is the equation to give this result. So this is the first part of the exercise. We have already an expression for output, and then we also need the rationing rule. So we need to add a formula to the variable rationing rule. And the rule should be such that it will reduce the value of output and demand components when final demand is greater than potential output, but have no effect on these variables otherwise. Plus, the effect of the rule, when active, must be exactly proportional to the ratio between the two variables. So again, we can use the function mean. And what do I mean that this rule must be exactly proportional to the ratio? Because if demand exceeds output, then the components of demand must be reduced exactly by the amount that this excess is in order to keep demand equal to output. And why is that important? Because the dynamics of demand must also be affected by these constraints, so that demand cannot keep increasing independently from what happens in the supply side, right? And then we include the effect of the rationing rule on consumption, investment, and government spending. So we have the variable rationing rule. Find it here, right? And then, I mean, we can connect with the variables before using it. So yeah. So why I'm using the delayed values of final demand and potential output? Because I want rationing rule to affect government spending, investment, and consumption. So if I want rationing rule to affect these variables, but I know that these variables are causing at the same time the final demand contemporaneously, then I could have a circularity if I use the final demand for the same period, right? So I need to use a delayed value in order to not have a circle in the terms of causality. So I would have a problem and the model would not run otherwise. Then I can open the rationing rule, and I can say this is the minimum between. So it's so this will multiply the variables, so we can reason in these terms. So when potential output is greater than final demand, then I don't need the rationing rule, right? So when this division between potential output and final demand is greater than 1, it means that potential output is greater than final demand. And then I will capture the value of 1 because 1 is smaller than the rate that I will get. And then I will not apply the rationing rule. Otherwise, if potential output is below final demand, then I will have a value that's below 1. And then the function will give me this value here. All right. And then I'll check the chat, but I don't think it's with me. Yeah. And then we can multiply the value of this rationing rule in each of the components of demand. So we can link it to investment, government spending, and consumption. As the diagram becomes more and more complex, but this is how it is. I mean, this is a good representation of what happens when you model dynamics. And then we can just multiply. So if potential output is above demand, we are basically multiplying by 1, so we are not changing the variable at all. If we have an active supply constraint, then we need to, the value would be different here, and the value of the component of demand will be reduced proportionally. So government spending the same. And we are going to talk about government spending in a minute.
Excuse me, Guilherme.
Yes.
Is there any reason why we couldn't apply the rationing rule directly to the final demand equation?
Thank you. Very good question. Thank you. Felix, right?
Yeah.
What happens here? If I apply it only to final demand, not to consumption, right? For instance, then I would be reducing this variable here, but this one would keep the dynamics that it has, right, from before. So the value of consumption could keep increasing, and like I would be, in a way, artificially reducing only demand without changing consumption. Then I could have other problems in the model, right? For instance, here, for instance, we have that consumption reduces part of my wealth that I accumulated in the past. So this reduction in the wealth would be the one that comes from the variable consumption. But this is not the actual consumption that I have because there is a potential output constraint. And the same could happen in investment or in government spending. So I could have the amount of government spending increasing continuously and only reducing here. But then I would, for instance, assume that after a few periods, the potential output is no longer constrained. Then the value of the final demand would be given by the sum of these variables, but they would be at a much higher level because they were not rationed when there was the constraint, right? So I don't know if I was able to be clear, but assume that we have a constraint during 5 periods, and I constrain only final demand and not government spending. It means that during these 5 periods, government spending keeps increasing, and then in the 6th period, when the constraint is no longer active, it will be at a much higher level than the one compatible to the final demand. So the objective is to avoid these distortions.
Okay, thank you very much for the explanation.
Thank you. So we rationed consumption, government, and investment. And then, okay, also good practice from a modeling point of view is to save your model because Vensim can be unstable sometimes. Then what we can do now is to think about economic growth, right? So we have components of demand working here. They are causing the final demand, but we still don't have an engine of economic growth boosting demand in this model. We have investment and consumption that depend mostly on income, and we have government spending for which we have set just a fixed value of government spending. We have an initial value here. So what the exercise asks us to do next we use, so of course, to keep it simple again in this model, we use this variable government spending growth. Here there is a growth rate for the government spending, and we can use this to dynamize the economic side of the model, so to push the demand and cause economic growth and increasing the output level in the model. So we use the variable government spending growth. We include the growth rate in the level of government spending. We also need to use government spending delay. So the past value of government spending, because I'm growing with respect to my previous value, right? And then we also create a new variable to measure economic growth, which computes the growth rate of output. So I'll start by connecting government spending growth, government spending delay with the government spending variable. There's someone in the chat. Since output is defined as a variable, not as a stock, overproduction period X cannot be consumed in period X plus 1. Can it? That means if more is produced than demand in the first period, then there's... Yes, thank you, Elias. Thank you for your question. So output is a flow, as it is in the economic analysis. In the national accounts, output is considered a flow. What we can have as a stock, if we have differences between demand and supply in economics, usually people consider the accumulation of inventories. So the part of production that's not sold is accumulated in the form of inventories. If there are mismatches between supply and demand, this can happen. So here, of course, we are not modeling inventories, but we have that output is exactly equal to final demand. So all the output produced here is consumed by assumption. So it's basically as if firms knew exactly what the demand is going to be when they decide how much to produce. So they have no surprises and no reason to vary the inventory in the simplified framework. So actually, this problem does not exist. So there's no risk of overproduction in the simplified framework. So, okay, we were just connecting these variables, and now we can say, okay, government spending depends on the past value of government spending times 1 plus government spending growth. So here, if we open government spending growth, government spending is assumed to grow at a 1% rate each period. So by doing this multiplication, we are just increasing the past value of government spending 1% each period, as long as this broad output is not supply constrained. And when we go to government spending delay, we just have the previous value government spending. So this function delay fix gives me the previous value of the variable that I'm considering. But then if I consider the previous value, I still have to define the initial value. So this is defined as an additional variable, which is exogenous to the model. So we have a given initial value of the government spending. Okay, we have another chat question. Could you explain the delays in demand, output, and spending? So this final demand delay, you mean? So this delay function, the objective of this function is to get like a lagged value of the same variable. So if we have government spending delay, we have the government spending one period before. And this is important because in this type of model, we want to avoid circular causality, otherwise the model does not work and it's not logically consistent. So we need to isolate these delayed variables and use them for the purposes that we want. So for instance, in the case of investment, since investment is causing the current final demand, but we know that in a way the firms decide to invest when they face more demand. We create this rule that entrepreneurs are actually looking at the previous period demand, so final demand delay affects the capacity utilization that the firms observe when they decide to invest. And then they set the value of investment based on that. So this avoids that the current demand is affecting the investment, whereas at the same time investment is affecting the final demand. So this is why I need the delay in this case. And then the similar reasoning holds for the other variables. Okay. Thank you, Temu. And then we want to create an indicator, right? So we have output. We want to know output's growth rate, right? So we come here, a variable 2. We create a new variable. Let's call it economic growth. Economic growth. It is necessary to create a new variable. Yes, it's necessary. You cannot use this function inside the other variables. It creates many problems in them. So economic growth is actually a comparison between the level of the output in one period and the level of the output in the past period, right? So when we are talking about GDP growth rate, we are talking about basically this ratio. So we need to connect the two output variables to this. So this is again another moment in which the delay is useful. And we have the economic growth. And then we can just divide the two variables. Or if you want, for instance, a percentage growth, you can just do this simple calculation. Then you get a growth rate that's similar to it's a percentage growth rate. And then this may make your graphical representation more interesting or something like that. So since we are not going to use this variable for as an endogenous variable of the model, it's endogenous because it's caused by the model, but it's not going to affect other variables. This is just an indicator. We can shape it as we want, as we like, because we are just going to see the results, how they appear here. Okay. Then we have just things in the chat. So we are done with the third part of the exercise. Then, if you're still with me, there are 33 people still there, so we can just quickly do the labor market part, because after we finish, we will be able to generate one scenario also with the economic side. So I'll try to be a bit quicker here. So now we have demand, we have output, but we still don't know how this generates employment. So we still have other green variables here that are not caused by anyone. So we have the employment level, the unemployment level, the unemployment rate. And we want to generate these results. So we know that there is a demand for labor associated with the amount of output that this economy is producing. But this amount of employment is also depending on the labor productivity. So we have a labor force, which is the number of people at the working age and participating in the labor market. So either these people are employed or actively searching for a job. And this labor force depends also on the demographic part of the model. So natality rates, mortality rates, the number of young people that are active in the model. On the other hand, the number of unemployed workers will be given by the difference between the total labor force and the number of employed workers, so by definition. Finally, with this information, we are able to compute also the unemployment rate, which is another fundamental socio-economic indicator generated in our model. So we can use the level of output to generate the employment, but we also know the labor productivity. So the quantity of output that I'm able to generate with a certain amount of employment So the total number of employees will be given by this, the division between the output and the labor productivity. So for instance, given the level of output, an increase in productivity tends to reduce employment in this model. Then we can calculate the number of people that are unemployed. So I just subtract those that are employed from the total labor force. We can open an employment variable, labor force minus employment. And finally, I can compute the unemployment rate. So is the number of people unemployed divided by the labor force. And there's something not working well here. Okay. So I think this was the last part of the exercise. So if you're still with me, if you have arrived until this point, we can run a scenario. So we can go, you can put your name or whatever. I just put baseline here. And I cannot see because there is the Zoom thing creating me a problem here. Okay. We can click in this green triangle. And if everything is correct, you should be able to run a simulation. Okay. And then I think that David did with you many times. You can open the, so I have another run here, sorry. You can open the variables and see how they behave in this model. So we have some weird results, but then we have, for instance, our economic growth rate, where economic growth, for instance, well, it falls in the future, probably because there's climate damage. So we have negative growth after a few periods. And if you want to change your views, we also have a results view where we have some graphs. So this results can be a bit weird, but then you just need calibrating a bit and changing the parameters and the initial values to get something that's more meaningful. But these were more or less the message that I wanted to pass. And then in the next lab, on Monday, you'll be able to test different scenarios and see like what's the economic and social and ecological meaning of each of them, and try to approach them in a way that you can generate some policies and work with these policies to improve the scenarios, improve the outcomes in terms of climate change and also employment inequality. Inequality, no, we don't have inequality, but employment or GDP, whatever you want. So any other questions or doubts? So there was, okay, another comments in the chat. They were to Robert. Okay, Einur, please.
Yes. Actually, I have a few questions. First, would it be possible to access the file that you have been working on to drive or something? Because I was looking at the lab folder and I couldn't find it. So if it is okay, so would it be possible to share it with the drive? And another question, not with the lab session, for the presentations that have been made today. There's only one presentation in the folder, so would it be possible to add the two others to the shared folder as well?
Okay, thank you. Thank you for your question. So the file that I'm using here, it's actually is in the shared drive, right? Other people told me that they were able to find. So
I couldn't
have a
find
look
it.
on the drive on lab 3 folder, and then you can download it. But then maybe you're opening, I think the file is opening in a different view. So you go there below and say select view, and then you put economy. And then you're going to see something similar to what we saw. So it's a day 3 underline template. This should be the file that's available.
Mm. Okay, I'm still not able to see it, but maybe it is me who have problems with accessing. I can see some files, but not the one that you described. Okay, no worries, I will try to find it.
But other people were able to, right? Or... Yes, okay. He did, like, yes, in the camera. Okay, so I don't know how to help you actually, but there's
Okay.
might be some problem in the drive or something,
Yeah,
or
probably.
wrong folder path, maybe.
Well, I could only see day 1. That's why I had trouble with following. Okay.
Okay, but also Roberta or Simone sent an email to everybody yesterday with the link to the folder. So did you receive this email? Or...
No.
Okay. Maybe have a look on your spam box. There, the correct address be there.
Okay, I will have a look at and reach out to you if I can't. Okay, thank you.
Thank you. And the presentations, if they are not yet there yet, but maybe you have the wrong folder, so they should be there,
Probably.
but, or they would be updated very soon.
Thank you.
Uploaded, sorry, not updated. Can you run analysis on what causes the output decline? So yes, this can be fun. We can quickly have a look. Could you or a colleague say something more about units in Vensim? Yeah, no, actually units play a role in the economy model. Yes, for sure, they are important. Units are a very useful feature of Vensim, but then this means that my model here is incomplete. So we should be introduce some units also because we have different measures. We have output, which is measured, I don't know, in euros, but we have labor, which is measuring number of people or number of hours of work. So we have to find a way to match them. So this is really important. This is one incompleteness of the current model. So share my screen again. And then we had, so we had economic growth, for instance, that's going very low, right? So we want to know what causes this to drop. So I can have a look on how demand is working. It's also falling a lot after reaching a peak, right? So something is causing this to fall. So I mean, this is like this type of thing happens when we try to model, when we are modeling. We find some weird result or some expected result, but we want to check how it was generated. So we go looking at the previous variables, what causes them, and we try to find out where this comes from, especially if something unexpected, right? So we can have final demand. These tools are also useful. So the causes tree, so it shows all the variables that come before. So the variables that come before final demand, and maybe there's a problem. There's something going on in some of these variables that are causing final demand. So I can have consumption, growth, government spending, or investment. And then I have each of the variables that causes those other ones. So we can look, for instance, to rationing rule, right? Let's look to the rationing rule. And we see that after a point, this becomes smaller than 1. So there is actually a reduction of demand basically on period 15 onwards, right? So this means that demand is exceeding the potential output in these periods and then is being decreased. And why this happens? So maybe we know that one of the reasons this may happen is that potential output. Okay, I'll have a look later on the chat. Because potential output is not following the pace of growth of demand. So we can compare these two variables, but then they tend to go together because demand is rationed according to the potential output. But then we know that potential output has 3 determinants. So it depends on capital potential output, on materials or energy potential output. So maybe I was not able to explain this very well, or I took for granted that you saw the other days, but basically the potential of production of the economy depends on the availability of capital, energy, and materials. And then if I click shift and I select the variables, I can put them in the same graph. And then by looking at them, I see which of them becomes more important. So I have a huge potential of production given the availability of materials, but then at some point this crosses and becomes very small. So this is what's reducing the potential output after period 53, right? 54. So the potential output of the economy is the gray line, and you can see that it increases more or less in line to the capital potential output, but then after this point, it starts to decrease. So basically in this scenario, there is a constraint in terms of availability of materials, and this is reducing demand and growth after some period. So we can go back this. And this is period 55. So it's just one period after this line is crossed. So this is exactly what's going on here. Okay. So, okay, a more theoretical question of the rationing rule. How is it meant to be politically implemented? Through inflation, through quotas measures? So, I mean, in a market economy, there is some type of rationing because you cannot have demand. You cannot demand more than what's available to be produced, right? So what happens in a market economy, in a capitalist economy, is that usually there is an increase in prices or some type of rationing, and then people are not able to buy all the goods that they wanted. So think, for instance, I don't know, about masks during the COVID pandemic. People wanted to buy face masks, but there was not productive capacity to attend all the demand because it was all new demand, unexpected in a way. And then the prices of masks went up, but also you were not able to find masks in the market, so you were not able to buy it. So it's not necessarily a political rule. It's a rule on how the economic system works, but we are just trying to formalize this in the model through this rationing rule. So as I was saying, in William, this appears more complex, in a more complex way, because they have a diversity of consumption goods in William. So you can have an increasing prices, and then these increasing prices reduces the value of real demand, and therefore you have a match between supply and demand also caused by this increasing in prices. And then the other question, is there a sensitivity analysis tool in Vensim? Yes, there is. I don't know if in the free version this tool is available, but in ours it is. Would be useful to use sliders to play around with variables? Yes. So again, we can have a look. So this is a dangerous tool because if you do not define very well the range for each slider, you can have some problems. But using this run simulation on each slider change, you can have the possibility to change the values of some variables, some parameters that are exogenous, and then see how the results change. So here I have only results, but then not. I have parameters separated from results, but say I want to, for instance, increase the sensitivity to climate change, so I can use the slider and increase this value, and then I can see, so I just use the slider, and then I can see how the results change. So basically unemployment start to increasing much earlier, right, I guess. So if you have, also here, if you use the sliders here, you're able to see how this graph changes, right? So it's useful to have them together with these graphs. But then, as I said, if you change them randomly without knowing very well what you're doing, you get errors in the model because some extreme values may appear or some problems may emerge from your model. So in this case, there's a floating point, so Vensim is not able to compute some simulation point because I changed this in a way. But so then if you stop this, and then you just go back to what you had before. So, but this is very useful actually. And then you can also use a sensitivity analysis to change, to add random shocks to specific variables and see how your simulations change after that. Yes, I agree with you, Felix. So depending on how this rationing happens, you can have implications in terms of equality and justice. So yeah, if it's a rationing based on prices, as in the market economies, usually rich people are able to cover and poor people are more punished proportionally. Thank you. So other questions or comments? David?
Yes. There was another question in the chat asking about again about the units. So yes, it's important to have units okay in Vensim. There is also a way to check that units are okay, but still the model can run even if the units are not okay. This is important to ensure, like as you said, logical consistency. Why in the previous labs we put some auxiliary units like Celsius and Euro is because the way in which units are checked is that the equation that is written has to have the units cancelled, or the units of each variable in some equations should in the end result in the units of the variable that we are describing by that equation. But there are some functions that have I don't know, for example, the normal function that we have for temperature requires all the variables to be in Celsius, for example. So we had to put this auxiliary unit Celsius to multiply some values by that so that the units are okay. What we did in the second day was that we just leave temperature without units to not complicate in this sense. But yes, it is important to make units correctly, and it's also very useful when you are modeling. You will see that units are very helpful for to understand what's going on. So it's important to have this logical consistency.
Thank you, David. Thank you all. So I think we can conclude here, and then we meet again on Monday, right? If I'm not mistaken.